Hello, my name is Ed Brown with Walla Walla Environmental, and today we're going to do a jar testing video. The first steps, of course, in doing any of this is making sure you have your proper PPE on, safety glasses, and gloves. The next thing that we need to concentrate on is calibrating our pH probe. I've already calibrated it into the 4 solution. You will notice the 4 solution is pink, 7 solution is yellow, and 10 solution is blue. The next step is to rinse the pH probe and then to remove the excess water from it. Notice I only dab on the bottom. I do not wipe on that glass. I insert that into my number 7. I wait for the probe to rest on a number and I hit the calibrate button. I hold that for 2 seconds and now it's calibrating. You can notice the light is blinking there. Your probe is now calibrated on 7. In proper care of our meter, we need to make sure that we always keep it wet, whether in a glass of water or water in the bottom of your cap. It can also be number 7 buffer solution. After calibrating our pH meter, we place 400 milliliters in each one of the 3 jars. Okay, our next step is to take a pH of each one of our beakers and record it in our record book on our sheet. Now we're ready to move to our coagulant step. I would recommend that you always do 3 jar tests to make sure that you're using the correct amount of chemistry. We have determined from reading the log book that on a normal day, you're using 1 milliliter of coagulant in your 400 milliliter jar test. So we're going to, in this jar test to the left, we're going to use a half a milliliter today. We're going to use 1 milliliter in the center jar test, and we're going to use 1.5 milliliters in the farthest to the right jar test. Always work left to right so that you stay organized, and then you also write that in the log book, left to right. And it says jar test number 1, number 2, and number 3. This is a sample of your coagulant. In this case, it is our product called Cat 30, and we're going to take out a half a milliliter into our syringe and place it in our first jar. We're going to then take out a full milliliter and place that into our normal treatment. And we've gotten that number from our log book. That's part of the reason it's important to keep an accurate log book and also to show anyone that has any questions what you have done in the past. Now we're going to go over some easy tests to know if I've got the correct amount of coagulant in my sample, and then how that's going to react in the tank as well. The first one I'm going to show you is called the wick test. This sample over here is untreated wastewater. You will dip the paper towel into the wastewater sample and you will notice that it wicks up completely black water. To speed our video presentation along, we're just going to dip into the center sample here, which I already know is the correct amount of coagulant for this wastewater, and we're going to see how the wick turns out on this sample. And as you can see, there is a little black line, and below that, normally sometimes that will all be black below the line there, but we're interested in this water above that line and see how it is totally clear. This wicking of the clear water tells you that you've separated the contaminant using the coagulant from the water, and then the water is free to travel or wick up the paper towel. Now I'm going to show you the blue glove test. Now for this test, it is very important that you do have this color of blue gloves. Even green gloves don't work as well, and black is totally, you cannot see it. So I'm going to demonstrate this for you now. This first drop is going to be untreated wastewater. And you will notice that you cannot really see the particles separating from the water there. It is all homogeneous and has not been treated correctly. Now look at the treated wastewater sample where you can see the particles and you can see the totally clear water. And the water is kind of running away, whereas the untreated water stays in place. Part of the reason that we go through all these tests of addition of coagulant is the coagulant addition is the very most important aspect of treating wastewater. And if the coagulant addition is not done to the proper amounts, you will not get clear water or good cake. So we want to use those two tests to make sure that we have added the correct amount of coagulant. Okay, our next step is to take a pH of each one of our beakers and record it in our record book on our sheet. We're now moving to our second chemical addition in our jar test, and this will also be the order that you put the chemistry into the treatment tank. We're going to add pH and sludge conditioner, or some of your plants are going to use caustic soda. Now, if you're using caustic soda, be extremely careful. That is the most dangerous chemistry that you will be using in this entire process. Do not allow it to get on your skin, in your eyes. Wash it off immediately. So pH and sludge conditioner, on the other hand, can sit on your skin, will not harm you. It will dry your skin slightly. And what we're trying to do here is raise the pH of this product back up for two reasons. One, the third chemistry needs the pH higher in order to find its window to work in. And two, for your discharge permit to your city, or if your water is going to your starch kitchen, we want a constant pH. So we're shooting for somewhere in the neighborhood of 7.5. Now, everybody's water is a little different, but we're going to use that number here today as our target where we want to hit. So we're going to add our pH and sludge conditioner to our various beakers, and we're going to mix that up with some sort of stir rod, and we're going to take our pH probe and insert it into the beaker. And remember that pH and sludge conditioner and caustic soda work very slowly, so you need to be kind of patient at this step, whereas your coagulant works very fast. As a reminder, 7.5 pH is our target. And once again, we want to record every one of the pHs from these jar tests and how much material we used approximately. Okay, now we're on to our third chemical addition. We're going to add our polymer to each one of the jar tests at this point. Now, the amount you add will vary according to plant, but usually for a 400 milliliter sample, it's somewhere in the neighborhood of 2 to 5 mils. So we're going to add that into each one of the samples, and then we're going to mix those samples up. If you give the samples time after you put the coagulant in there, you will notice that the solids will settle out and the clear water will show. This is one good indication that you have the correct amount of coagulant in the sample jars. In recapping our process, we're starting with 400 milliliters in each jar. We're taking the pHs of each jar, then we're adding our coagulant. We're mixing that. We're once again taking our pH. Then we're allowing that to settle for just a minute to see if we've got clear water. We're then going to our second chemical addition, which is going to be our caustic soda or our pH and sludge conditioner. We are mixing that. Now remember, that's a slow process that has very slow chemical tendencies to it, so you have to be a little patient there. Mix that, once again take our pHs, and our target is what? 7.5. Now that will vary with everyone's water, but that's the target we're going to shoot for. Then we're going to duplicate that in our actual treatment tank utilizing our formula that is on our jar test log sheet. So if we have used 0.2 milliliters of a product in a 1,500 gallon batch, we're going to use 0.75 gallons. And look at your log sheet. It should be listed on there how much you need to use. As part of our service to you, we provide you with a log sheet that makes it easier for you to record your findings in your 3-jar test and then make the calculations for what you're going to need to put into your treatment tank. Thank you for joining us today. And if you have any questions, please contact us at area code 509-522-0490. Thank you and have a great day.